Hi, this is Mr. Ring going over the Precalculus quiz number 7, sections 2, 2.1, 2.3, taken on December 5th, 2018. Multiple choice, circle the best solution. Question number 1, write the expression in the form of a plus bi. A is the real, and then the bi is the imaginary. You have a division problem. On division here, basically in the denominator, we can't have any radicals. Essentially, I is the square root of -1, so what you have to do is find its conjugate. The conjugate is just changing the, once it's in the real and then the imaginary, in this form, a plus bi, all you have to do is change the addition sign, in this case, to subtraction. And the reason why you do that is because then it has difference of squares and then basically eliminates it. So 8 minus I and -6 minus 2i, that gives you -48. Positive 6i, -16i, and that becomes positive 2i squared. Remember, I squared is equal to -1, so that becomes a -2. So I just wrote those here in the numerator. So that becomes a -2, and so -48 and -2 and -16 gives me -50. Missing something. Oh, there's an I here. And that becomes -10i. In the denominator, -6 plus 2i and -6 minus 2i. Positive 36, -12. Again, if you get confused what's happening there, you're multiplying first, and then you're adding or combining like terms. Positive 12i, and then -4i squared. Here you'll recognize, again, the difference of squares that eliminates those two terms. You're left with 36. -4i squared. I squared is equal to -1. So this does not say -4 minus 1. This is -4 times -1, which is positive 4. And you get the 40. Here, if you recognize that all of the coefficients has a factor of 10, then you can just factor out a GCF of 10 both in the numerator and denominator. Remember, you can always check your answer by distributing. That gives you -50, -10i, and 40. These 10s will cancel. You're left with -5 minus I over 4. And essentially, if you put my finger over it, this is -5/4, which is the answer above. Answer above. Answer above. There. And then -I over 4, or -1, or -1/4 I, which is choice A. So the big idea for this problem is you should be able to just find its conjugate and then simplify. Question number 2, if I made a mistake, the answer is A, and you were graded on B, so when I call you guys up for your homeworks in the last 5 minutes of class, if you and your partner have that mistake, just show me, then I'll change the score on Aries for you. Let me explain why it's A. Thank you, Nelson, for pointing that out. Use the polynomial f of x equals -2x³ plus 4x minus 8. Explain how the degree and the leading coefficient will affect the behavior. The degree in this problem is a power of 3. And if it's to the power of 3, it's a cubic. Starts down, ends up. The leading coefficient is this right here. It's just the minus sign. So when you see the word leading coefficient, it's just a minus sign. So what does it do? Well, if it's a cubic, it's going to look like this, but then if we have the leading coefficient, it's going to change. Okay? So your graph is ultimately going to look like this one here in red. Okay. So, odd degree, this is why C and D are wrong. It says the degree is odd, yes, but it says the endpoints will point in the same direction. Basically they're describing an even, so that the answer is, that's not possible, so I crossed it off. Again, same direction, no it's not, they're in opposites. Now we're left with just A and B. Let me explain why B is incorrect. it says, because the leading coefficient is negative, the graph will decrease from right to left. So here's right, here's to left. Is it decreasing? Is it going down? No, it's going up. So the wording was a little bit weird and made you think. The reason why it's A is because the leading coefficient is negative. Yes, we already know that. And the graph will increase, meaning going up from right to left. See how my graph is going up there? So that's why it's A. Again, show me a lot at the end of class, and I'll give you and your partner points. You just have to tell me who your partner is. Question number 3. Multiple choice, factor completely. You have x to the 4th minus 8x squared plus 16. When you have a trinomial, the question is, how do you know that you can factor this? If you take half of 4 is 2, which tells you can just use the x box method. Now, you could, at the time of this quiz, you guys did not know the rational roots theorem. But now you do know the rational roots theorem, so you can actually apply that. But back then, all you knew was to do a substitution. We did these in class, where if your w is equal to x squared, so x squared to the 2nd is x to the 4th, negative 8x squared. Notice I put those in parentheses, and then plus 16. So essentially that means you're going to put a w for every time you see x squared. Here is x squared, so you're going to write w. I see x squared, you're going to write w. So you get, in this problem, w squared minus aw plus 16. And if you factor this, a times c is 16. Your b value is negative 8. Two numbers that multiply to be positive 16 and add to be negative 8 is negative 4 and negative 4. And then you just go back and put in your w. W is equal to x squared. And then you should not stop there, because you'll recognize by multiple choice that none of these are the answers. And then x squared minus 4 is the same thing as putting that placeholder, x squared plus 0x minus 4. And if you factor that one, two numbers that multiply to be negative 4 are positive 2 and negative 2, but add to be 0. So your answer is x plus 2, x minus 2, x plus 2, x minus 2. And then you have two x plus 2s. And you have two x minus 2. So the power of 2, the answer is E. Question number 4. All I did was just flip the chart from the previous quiz or test. Circle the correct answer. The degree of the polynomial is odd. Remember, odds. The easiest odd you know is to the first power, it's linear, starts down, ends up. Okay, so when they're in opposite directions, that's an odd. If they're the same, they would be even. Okay. What is the leading coefficient? The leading coefficient in this problem must be a negative. What is the leading coefficient? A leading coefficient is this negative sign in front. It's leading. It's in the front. What does it tell you? If this is negative, it's going to switch these. So it starts down, ends up, but if there's a negative leading coefficient, it's going to start up, then end down. So your leading coefficient in our problem is negative. These were 1 point apiece. And when it says end behavior here, 2 points, that meant these were 1 point apiece. The left side goes up, and then as you go towards the right, it's going down. Question number 5. Factor completely. Anytime you're factoring, you should think about number 1, first, the greatest common factor. The greatest common factor in this problem is x. Well, if you have x as your greatest common factor, then you need to basically put all of this and factor that. Well, it's a trinomial, and you can just do a times c, which is negative 72. Your b value is negative 1. Two numbers that multiply, or the product is negative 72, but their sum, or when you add them, equals negative 1. So if you get stuck on this part here, you can do a strategy I like to do is write out all the factors of just 72. So 72 times 1, 36 times 2, 3 times goes in there twice. 1, 24. 4 goes in there once. 32 is 8. 6 times 12. 8 times 9. And the reason why I do this, and I put the bigger number on the left side, is so if you subtract going this direction, then you're trying to look for a number that's just 1. Well, that number there is going to be 9 and 8. The question is, what combination of positive 9 and positive 8 gives you negative 1? So that would have to be negative 9 plus 8 gives me negative 1. And that's why I put here x minus 9, x plus 8. So this would be your answer, and that is choice C. D was a distractor because they just changed the pluses and minuses. If I wanted to do a really hard problem, if I had to make it more difficult, I would have put one of the choices as x minus 9, x plus 8, which would have been incorrect. Question number 6. Tells you to factor completely 6x squared minus 25. Notice in this problem it's missing a placeholder. Why do I want a placeholder there? So I can factor it because it's a trinomial. A times C is negative 16,000, and the B value is 0. Two numbers that multiply to be 1,600 are 1,600 times 1 and 40 times 40. Well, anytime you have a B value that's 0, these numbers will be the same. One's positive, one's negative. You're not done yet. You're going to take this positive 40 and the negative 40. You will always put it in the bottom left and the top right. You're going to put the first term here, and then the last term here. And if you've been following along in class, you'll recognize something. You'll recognize that this box method is actually factoring by grouping. Let me show it to you really quick. So you have 64x squared plus 40x minus 40x minus 25. And then you can just take the greatest common factor, which you actually see right there, which is 8x. The greatest common factor, which you see right there. And then you factor out again, and you'll get 8x plus 5 and 8x minus 5. Remember, to check your answer, you can always multiply. Front side was out of 16 points. Back side. For your response, make sure to show all your work and box your answers. Okay, you were given 3 zeros and tells you to write an equation in standard form. Standard form says no parentheses. Well, get them into parentheses. If you recognize what you have first, they have given you factors or x-intercepts. It's telling you that the x value is 1 and the y value is 0. Well, if I know that x is equal to negative 1, positive 1, and positive 1, some students are like, Mr. Ng, was that a typo? That you have 2, 1, zeros? No, that's the idea of multiplicity. That means you have a even there. You have a bounce or kiss. Here I'm going to... if it's x equals negative 1, if you just add 1 to both sides, you'll get x plus 1. So there's the binomial I needed. Here, if you subtract 1 from both sides, you get x minus 1 equals 0. There's the other binomial, and then binomial. This idea here is that if you multiply... Which ones did I multiply? These two. That was using this box here. No, I didn't do that. Sorry. It was these two. X plus 1, x minus 1. X squared, 1x, negative 1x, negative 1. You'll notice that the middle terms there cancel. So you're just left with x squared minus 1. Let's try a different bolder color. I multiplied these two and got this purple box. And then if you multiply these two, you will use this box. We've been working on that. It's a binomial, 1, 2, times a binomial, 1, 2. So 2 times 2 is 4. This box has 4. X squared minus 1 x minus 1. Again, the order does not matter of which binomial you put. And you're going to do the same thing. You're going to multiply and then add x cubed, negative 1x, negative 1x squared, negative 1, positive 1. And then you have writing in descending order. That basically means the exponents 3, 2, 1, and 0. So you have x cubed, negative x squared, negative x, and a positive 1. So here is a polynomial with these x-intercepts in standard form. If you just got down to the correct binomials, then I give you 2 points. If you were multiplying and doing something correct there and going towards this direction, I give you the 3. Question number 7. Graph the polynomial and make sure to label the x-intercepts. Well, in this quiz, I asked you guys not to use your calculators, and that's kind of like the whole point, is that you're actually learning how to graph these without your calculator, and the calculator helps you. So you have x cubed plus 2x squared minus x minus 2. And at that time, again, you guys didn't know the rational roots theorem. The only thing you guys knew was factoring by grouping. How do you know to factor by grouping in this problem? Is because you have 4 terms. 1, 2, 3, 4. So again, you have 4 terms. You're going to factor by grouping. What does that mean? You're going to look at these two right here and see if they have something in common. They have an x squared in common. And then you look over here. You look, what do they have in common? They have a negative 1. Okay, this is where students went wrong. Yes, you have an x plus 2 in common, so your greatest common factor is an x plus 2. The common mistake I saw in grading your papers is a lot of students wrote x plus 2 squared. That would be incorrect. How do you go from this step to the next step? You can do something like this. You can distribute this whole purple box. X plus 2 times negative 1. Looks like that. X plus 2 times x squared. Looks like that. If you have the x squared there, the reason why it's wrong is if you expand it, you recognize you won't go back to the original polynomial. Well, how do I graph this now? I set this, each of these equal to 0, and you're going to get negative 1, 1, and negative 2. Remember, x squared minus 1, if you guys are factoring this, some of you guys made some mistakes in your algebra skills there. X minus 1 equals 0. So you would add 1 to both sides, you get x squared equals positive 1. And then we take the square root of an equation, you should have x equals plus or minus 1. That's why you have a negative 1 and a positive 1. Okay? Now, how do you graph a factored polynomial? Well, you just use the multiplicity. What's the multiplicity? The multiplicity is just saying, taking these numbers, negative 1, 1, and negative 2, and then looking at what their exponents are. So if these are all 1s, that means their degree is all 1s, and that's called a shoot-through, or goes through the x-axis. So then I label it negative 2, negative 1, and 1. I'm going to look for my basic graph. My basic graph here is x cubed. And I know that there's no negative here, so it's going to start down and up. So that's why I put my blue arrows here. So I'm going to go through negative 2. There's my turning point, right? Because I have to go back through negative 1 and go through back up 1 to go to that blue line there. And that's how I draw my graph. And you also have another clue there. Your y-intercept is if you make x equals 0, your y-intercept is negative 2. If you got the factors, I gave you 2 points. To get the third point, I wanted to know multiplicity. I wanted to kind of show your work for multiplicity. And that's how you would get the fourth point. So 2 points if you have the zeros. Third point if you're telling me what's happening with each of those x-intercepts. Question number 8. Make sure to label all your graph and make sure to label all your intercepts. So what's the difference between those two problems? Question number 7 was not factored. This one's already factored. So you already have factors. So you just need to find their 0. So which means zero product rule, set them equal to 0. You have x equals 1 here. You have, okay, now it says power of 2. That essentially means that you don't really want to do the same problem twice. You could, and you get x equals negative 3. A lot of you guys got kind of stuck on this one, negative x squared. So if you made, if any variable that's out there, you could have made it something like this, x minus 1, and then a parentheses there, and then power of 2. Now, or you could just set it equal to 0, divide both sides by negative 1, take the square root, and you get x equals 0. So I have x equals 0, I have negative 3, and I have a 1. Then you're going to look for its degree. So the degree of x equals 0 here is a power of 2. X equals negative 3 has a power of 2. And x equals 1 has a power of 1. So if it is an even degree there, we're going to kiss or bounce, and then a shoot through. So then I'm going to mark up, cross that part off. I'm going to mark my x-intercepts, negative 3, 0, and 1. To get my end behavior, I know it's to the 5th power. How do I know it's the 5th power? 2 plus 2 plus 1 is going to give me to the 5th power. 5th power is odd. The easiest odd is 1. Starts down, ends up. Because the leading coefficient here is negative, therefore it's going to change. So it's going to start up and then end down. So here in red and here in red. So as I approach the pink, we're going to have to do a bounce. Then I have to go back another bounce or kiss through at 0. And then through the blue and going to this red point, I'm going to have to shoot through. And this one is, oh, you can, it's right there, 1. So labeling, if I circle labeling, that means actually writing the number on your x-axis of those numbers. Again, if you got to the x-intercepts, I gave you 2 points. If you're showing me the work for the multiplicity, I want to know what's happening in your characteristics. And then the 4th point is an accurate graph, or at least labeling all your x-intercepts. Question number 9. Convert the polynomial into vertex form. So when you see vertex form, you should have y equals a times x minus h squared plus k. This should also give you a hint that you know that you're going to be completing the square in this problem. Well, if you look at this value and you know that you can't factor this because you're going to have to get a perfect trinomial square, you're going to have to take your b value, which is negative 4, and complete the square. My equation is b over 2 squared. My b value is negative 4. Half of negative 4 is negative 2. Negative 2 squared is 4. If I add 4 to the equation, I'm also going to have to subtract 4, because if you cover those up to equal 0, you get the original equation. Here, in this problem here, I can't take out a greatest common factor. Do you see that? You'll notice when to take a greatest common factor if you have like a 2 right here, or a 4, or something like that. Then you're going to put parentheses here. You're going to factor that problem. A times C is, let's use my colors. No, I can't use that color. A times C is 4. B value is negative 4. That means that it'll be x minus 2, x minus 2. Negative 4 plus 1 is negative 3. There's 2 of these, so you have x minus 2 squared minus 3. If you put the form right above it or below it, you'll get an h value that's 2 and a k value that's negative 3. Vertex is 2, negative 3. We have a y-intercept of 1. X-intercepts were not important, or you could by using the quadratic formula. Each of those problems were worth 4 points each, and that was 16. And the total test was out of 32.